All right, today we're going to talk about kinetic theory, and kinetic theory is going to help us understand why we have different phases of matter, why we have solids, liquids, and gases. So most of you know what a solid, a liquid, and gas is, but why is it that certain things are in a solid state, or why is it that certain things are in a liquid state, and what is causing them to change sometimes from one state to another? So to help us understand this, we have what's called the kinetic theory. And the kinetic theory helps us understand why we have the different phases and also just some other things about the behavior of matter. So there's three things that you're going to record in your notes that kinetic theory says. So this notes page, down here at the bottom, there's a little spot that says kinetic theory. You're going to put down these three parts of kinetic theory. The first part just says everything's made up of small particles. It's made up of atoms. It's made up of molecules. And so that's just kind of a basic understanding that explains the things that we see. And those particles are constantly moving. So it says we believe everything's made up of small particles. We believe that those particles are continuously moving. And so because they're moving, they have kinetic energy. That's where the word kinetic comes from for the theory. The third thing it says is that if you want to change the amount of energy or the movement of those particles in a certain substance, you're going to have to either change the temperature or you can also change the pressure. We're not going to spend a lot of time talking about changing the pressure. We will talk about how changing the temperature changes the amount of kinetic energy the particles have and therefore will make them either move faster or make the particles move slower. All right, so we have our three states of matter that we've been learning about, and the difference between those three states are going to be one of three things. It's going to be how the particles are arranged, how strong the forces are that are holding the particles together, and then also how much kinetic energy, how much movement, how much those particles are moving. And so those things, kinetic theory, can be used to explain how solids, liquids, and gases are different. All right, so you also, on your notes page, your handy dandy notes page, you have a little chart that we're going to fill out with some different properties about the three states of matter. So the very first one is volume. So we're right here on volume, and you see that it says that a solid has a fixed volume, liquid has a fixed volume, and gas is not fixed. That just means, remember, volume is how much space something takes up. So fixed means that a solid is going to take up a certain amount of space. You're not going to be able to squish it together to make it take up less space. If you take a block and you dump it into another container, the block's going to take up the same amount of space. Same thing for liquid. If you have a cup of water and you dump it into a bigger container, that cup of water still takes up a cup's worth of space. It's not going to expand to fill the space. It's not going to be compressed to take up less space. It has a certain fixed set space that it takes up. Now the gas, notice that the gas says it's not fixed because the gas is going to either spread out to take up the space or it can be compressed and squished down to take up a smaller space. So on your notes page, you can use the words fixed, fixed, and not fixed, but only if you understand what that means. If you need to put it in other words to make sure that you understand that that means the solid takes up a certain amount of space, so does the liquid, but the gas can either expand or be compressed. Make sure you do that in the little box for your notes. All right, the second property is going to be the shape. So we know that the shape of a solid, it can hold its own shape. So we say that it's fixed. Again, that means it's set. It has a certain shape of its own. It doesn't take the shape of the container that you put it in. That's different from a liquid and a gas. Liquids are not fixed in their shape, and gases aren't either. Liquids and gases are going to take the shape of the container that you put them in. So again, you can use the words fixed, not fixed, but only if you understand what that means. If it is easier for you, say that the solid holds its own shape and that liquids and gas don't hold their own shape. They take the shape of the container that they put in. All right. The next one is compressibility. Ooh, there's a big fancy science word. Compressibility means I need to go back. Can I squish it? Can I take the atoms, the molecules, the particles, and squish them to pack them together more tightly to make them take up less space? And the only one that can do this, you can see, is a gas. Because a gas, those particles are really far apart, and they can be squished and pushed closer together to take up less space. If you've ever heard of compressed air, if you have a little can of compressed air that you use to clean off your keyboard, that is based on this property of gases being able to be compressed. They can take up less space. And liquids and solids cannot. They're not going to be able to be pushed closer together, the particles. The density, so we're ready for density on your chart. The density decreases as you go across from solid to liquid to gas. So solids tend to be, it depends on the particular solid, but in general, solids tend to be the most dense, liquids a little bit less dense, and gases are not very dense. And that kind of makes sense because think about gases, those are the things that gases are going to float up. So if you have here in my cup, I've got some tea and I've got gas, well, the gas is on top because it's less dense. Think about in a fire, they tell you to get down on the ground and crawl because the gases that are produced from the burning are less dense, so they're going to float up to the top. And then the last on this page is the arrangement between the particles. So in a solid, those particles tend to be packed pretty tightly and in an orderly arrangement. In a liquid, they're kind of flowing and moving around each other, so they don't have that kind of more rigid, tight, packed arrangement. And then in a gas, they are far apart and random. They are just going all over the place. All right, so that's going to get us through 1, 2, 3, 4, our first 5 rows of our notes, and now we're ready for the next rows. Okay, the force of attraction between particles. For a solid, the particles have a strong force of attraction between them. And so they have to have energy added to them to overcome that force that's holding them together. You're going to have to add kinetic energy. You're going to have to add heat to them, increase their temperature to get them to have enough energy where they start moving enough to break out of those spots to overcome that force of attraction that's holding them together to then change into a liquid. In a liquid, they do have some strong forces that are holding them together, but they're not as strong as a solid, not as weak as a gas. And in a gas, once they have enough energy to become a gas, there's pretty much no force of attraction that are holding those gas particles closely together. So when we say negligible, that means there's none. There's basically no forces of attraction holding it together. Our next row is the motion of the particles. We saw this when we were doing our Explore Learning gizmo. You could see that in the solid, when the water was in the form of ice, that the particles were still moving. They still have kinetic energy. That's what kinetic theory says. All types of matter have kinetic energy. They're still moving, but they're in their fixed position. They are just kind of vibrating or moving in place. Once they have enough energy to be a liquid, they're sliding and rolling past each other. We saw this in the gizmo as well when you could look at the molecules under the magnifying glass. And then the gases are just zipping around and moving at a very, very high speed. That also ties in with the amount of energy. And you can just draw this across your row on your notes page. Particles in a solid have the least amount of kinetic energy. They're moving the least amount. Particles in a gas have the most amount of energy. They're moving really fast and they have a lot of energy. It's like they're hyped up on caffeine and they're just bouncing all over the place. Lots of caffeine and lots of sugar. And then in between, that's going to be the liquids. So they have a moderate amount, a medium amount of energy. All right, and then we're ready to draw. So just in this last row on your notes page, you're just going to make a little drawing that represents what do the particles in the solid look like, the particles in the liquid, particles in the gas. And if you need to add or you make your drawing a little bit better than mine, go for it. So you can see here, this little video is just going to show you an example of the motion of the particles, how much kinetic energy each of these particles have in the different states. So they have a little bit of kinetic energy here, they're moving more and have more kinetic energy